Okay, so in this video we are going to reintroduce a topic that we've talked about before, which was minimum completion time. Now we defined this thing in previous videos as when we get to this last vertex, when we get to our finish, that is basically the time that we see over here, which is basically when the activity is complete and how long it's taken. In this first example, this is in hours, but what we're going to extend in this video is applying what we learnt in the critical path and thinking about if we were to lower the time in some of the activities, which is what happens in the project. You can figure out ways to speed up certain parts, which activities will impact on the minimum time decreasing and which will have no impact on the completion time. So going through this first example, A is just a recap of what we talked about in the first part. So the minimum time looking at the end here is 13 hours. That's pretty straightforward. We're just looking at this last vertex where the finish is. Now, this is saying that which of these activities, if reduced in time individually, would not result in an earlier completion of the project. Now, these ones that do not result in an early completion are the ones that are not on the critical path. So whether we change A, B, or C, it won't matter because we're limited by the critical path. That's what we talked about in the previous video. This part here, which is highlighted, now remember the critical path is the path that where these earliest start times and latest start times are the closest together. So we can't afford to be late on any of these things. Now, the activities that are in question here that will not result in an early completion is going to be activity A, B, or C. Let's just think about this for a moment. If I rub this all out and consider why. Say we reduced C by, looking at activity C here, let's say we reduced this by 2 hours, okay? So we reduced this to maybe 1 hour, okay? Now, what this means is that from here, all we would be reducing is the latest start time. Now, if we were to, for example, backwards scan here, if C was reduced by 1, it was reduced down to 1, the latest start time, sorry, wouldn't reduce the latest start time, the latest start time would change to 12 instead. So all we'd be doing by reducing A, B, or C is just changing the latest start time, but this makes no difference to us. We can wait to do these activities. The ones that will actually reduce are the ones along the critical path. So A, B, and C have no impact on the completion of the actual task, because the only ones that will are the ones on the critical path. That's what we want to look to shorten. Now this is saying in part C, activity D was reduced in time to 4 hours. What is the new minimum completion time? So let's consider changing this guy here to 4. What that would do was it would change the earliest start time of activity E to 4, and it would change this part to 11. Now, because this is still on the critical path, these are just going to change here. So from 11, that goes down to 4, and this one goes down to 0, basically. So changing something on the actual critical path will change the minimum completion time because these are the most important activities. These are the ones we can't wait to do because their earliest start time and latest start time are exactly the same. So now the new minimum completion time for this task is going to be 11 hours. By reducing something on the critical path, we reduce the total time taken for my project, for our project, I should say. Now with example 2, this is a little bit more complex and it's kind of a wordy question, but we can work through this in the same kind of way we talked about before. Now the first time is saying what is the critical path and the minimum time in weeks to complete this project. Now in order to do that, we want to trace along to these vertices where the earliest start time for the next activity and the latest start time are exactly the same. So beginning at the start, we are going to go to this one here. We've completed activity B. Now activity C has an earliest and latest start time of 4 and 4. So we're going to go down this C edge. Then we're going to go back up to here. Then we go to here. And finally to here. Now you can see along all of these vertices, if I look at the earliest and latest start times, they are all identical, meaning that this is the critical path. We have to follow this because there's no time to waste, basically. We need to do these tasks straight away. So let's actually clear this up. Our critical path is going to be B to C to F to H then to I. And this is going to take 19 weeks. We find that by just looking at that finish vertex. So this is going to take 19 weeks. Okay. Now it's saying in part B, the builders of the community center are able to speed up the project. Activities A, C, F, and G can be reduced in time at an additional cost. Which of these activities, if reduced in time individually, would not result in an earlier completion of the project? Now, if we understood what we were talking about earlier, we are just looking at the ones that are not on the critical path. Those that are not on the critical path, whether we reduce them, no matter by how much, it will not actually impact on our project getting done earlier. It will just increase the latest start time for that thing. So we've got to see which of these ones are on the critical path. So the ones that would result in an earlier completion. Now, C and F are both on our critical path. So these would result in an earlier completion of the project. So the ones that have no impact on the completion are the ones that are not on the critical path. So A and G here. Okay. Remember, the wording is tricky, but we're looking at those that would not result in an earlier completion. The ones that would not result in an earlier completion are always the edges and activities that are not on our critical path. Now in part C, it's saying the owner of the estate is prepared to pay the additional cost to achieve early completion. The cost of reducing the time of each activity is $5,000 per week. That's saying the maximum reduction in time for each one of the 5 activities, A, C, F, and G, is 2 weeks. And that's a typo, it's meant to be 4 activities. Find the minimum time in weeks for the project to be completed, given these activities are reduced in time. So if we clear this all, we are looking at, if we want to reduce the time, okay, we have to pick the activities that are on our critical path. So that is going to be C and F. So these two here, we want to reduce. So C is going to change from 3 weeks to 1 week. F is going to change from 4 weeks to 2 weeks. Now, this is really significant because we've reduced our time basically here. Now, some of you may be thinking, well, cool, I can just subtract 4 from 19 and I have my answer. We can't necessarily do that because we need to consider the updated network diagram with these new weights on our edges, new times for these activities. So we need to draw a new network diagram with these alterations, C being 1 week and F being 2 weeks. The reason we're not just going to subtract this is because now that these have been reduced, we may get a new critical path once we complete our updated network diagram. So you can pause this video if you'd like to have a go at forward and backward scanning with these new conditions here. But I will scroll down now to show you what the updated network diagram will look like. Now, you can see here that I've reduced these, and when I forward and backward scan, I notice that my critical path has actually changed. Because of this reduced time, now, if we look at all of the vertices that have the same earliest start time and latest start time, this thing actually changes. Now our path goes from B to C, B to here, so we've completed activity B. Now we go to activity E. Then we go to activity H. Then we go to activity I. So in drawing this, you can see this when you forward and backward scan this all on your own, that basically we get a new critical path. So if you're not sure how to do this, go back and practice drawing these boxes in showing the earliest start time and latest start time. This is a prerequisite for this particular activity, so you can see how I got these actual numbers. But now that we have a new critical path, our time at the end has changed. Now it hasn't gone down by 4 like we expected. It's gone down by 3 because a new critical path has been made. So the new minimum completion time is going to be 16 weeks. So hopefully now you can see the effect of activities that are on the critical path or that are not on the critical path, and how they can affect our project. Now, if you're a project manager or you're doing any kind of activity, the ones you want to reduce, in order to reduce the minimum completion time, is going to be the activities on the critical path. There is no point in reducing the ones earlier, because as we saw in this example, it just gives you a later start time. So it just gives us more time to wait, basically. It doesn't actually, picking an activity that's not on the critical path doesn't actually reduce the minimum completion time of our project. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.